And welcome back. And we're on to the 28th of Jan, and it is the 5-a-day for further maths. And let's go with the first question, shall we? Okay, so what do we have? So shown is below is a triangle DEG. Okay, let's mark this on the diagram actually. So DE equals DF. So we have an isosceles triangle, and DF equals FG. Oh, is this over here? So we have two isosceles triangles. And then it says FDG equals theta, which is marked on the thing already. Prove that. Now, as I've done in previous videos, I'm not going to write all of it down because otherwise you're just watching me write, but you need to make sure in an exam you're writing the words down that I say. It's probably worth just having a quick look at how I think it's going to work just before we start committing pen to paper, because otherwise you're going to write a whole load of stuff and you might be going the wrong way. So the way that I think this is going to work is I've got theta here, which means that this must also be theta because it's an isosceles triangle, which means that this here must be 180 minus 2 theta, angles in a triangle. And it means that this one over here is going to be 180 minus 180 minus 2 theta, which is also known as 2 theta. Now, because it's an isosceles triangle, that means this is also 2 theta, which means that this one is going to be 180 minus 4 theta, which is the thing I'm trying to show. So that's going to be my method. So let's just then talk about how we're going to put all that together. So what you're going to say, and again, I'm going to give you a really brief version here just for your sanity and mine. So I would write that FG, so angle at GD, is equal to theta, and you need to say base angles of an isosceles triangle are equal. So let's write that one in so we've done it. Then I would say DFG, so DFG is equal to 180 minus 2 theta, because angles in a triangle, don't draw a triangle in your exam, angles in a triangle total 180. Then I would say, so let's write this in as well, so 180 minus 2 theta. Then I would say angle DFE, so angle DFE equals 2 theta, because angles on a straight line, let's write it so you can actually read my writing, so straight line total 180. And again, it's these keywords they're looking for in an exam. So I now know this is 2 theta. Now I can say FED, it's slightly tedious, but it's not a terrible question. FED equals 2 theta, because again, base angles of an isosceles triangle are equal. And again, you're writing the words are equal. It's important you just write all this, not just my summary short cheat version. And so therefore that means that angle EDF, so let's write what's in the question. So EDF equals 180 minus 4 theta, because angles in a triangle total 180. These questions are a little bit tedious, but equally they're fairly easy marks. Like I say, work it out first, then do your thing. And one really good thing to do is angle, reason, nice and clear. One of my students a while ago just wrote a list of reasons down the side of the page. Doesn't count. I have to see the reasons connected to the thing that you're doing. We got there eventually. Next question. Let's hope there's some algebra and not any more proofs going on. Okay, next question. We have y equals x cubed plus 4x squared plus 2 when x equals 2. Show that. There's a show that question, so I need to make sure I'm showing clearly what I'm doing. So I'm going to write up here that dy dx is equal to 3x squared plus 8x plus, well, not plus anything, it goes away. Okay, so let's show that question. So I need to show some working in between. I can't just write down the answer, even though it's reasonably straightforward. So I'm going to substitute it in. So I'm going to say that when x equals minus 2, dy dx is equal to, so it's 3 times minus 2 squared, which is 3 times 4, which is 12, plus 8 times minus 2. Let's write the step in between because it wouldn't take us that long to do it, would it? So 3 times 4 is 12, minus 8 times 2 is 16, and that equals minus 4. And I have shown that to be true. These show that questions tend to be 1 or 2 marks. So as long as you've got a couple of lines of working, you should be okay. Next question. Angle PQR equals 90. Cos theta equals 12 over 13. Work out the equation. Right, okay. So this is a straight lines question. So the thing that matters here is because that's 90, I'm thinking perpendicular. So in other words, if I can work out, I don't really need the equation, but I need the gradient of the line Q to P, and then I'm going to negative reciprocal that number, and that's going to allow me to work out Q to R. But I can't do that unless I know what this point here is, because I need the point Q so I can work out the equation, the line. What else are you doing? Let's first of all think about why I'm given this here. So cos theta equals 12 over 13. So theta is here. So let's draw the triangle over here, because I think I know where this one's going. So cos theta is adjacent over hypotenuse. That's 12 over 13. It's a 5, 12, 13 triangle, so you can test it. So 13 squared minus 12 squared, square rooted is 5. So 5, 12, 13 triangle. You need to get good at spotting that. Now what's interesting is this number here is 36. So in other words, I can scale up this triangle by 3 times, can't I? Which is going to give me 36 against 15 and 39. And the reason that's important is because that allows me to note that Q is 0 minus 15. And I've got my Q value. The other thing it allows me to do is it allows me to work out the gradient of Q to P. And the gradient of Q to P goes across by 12 and goes up by 5. So in other words, it's going to be 5 over 12, which means the negative reciprocal, in other words, the gradient of Q to R, stop moving, the gradient of Q to R is minus 12 over 5. Wow, what a question. And actually it's not that bad, is it? Because I've got the intersection, so I've got my C value, so actually we just put this together. So therefore y, which is the line QR, so y equals minus 12 over 5 times x minus 15. That felt a lot worse than it actually was. But again, another really nicely worded question. Get you thinking a little bit about how to set these things up. Well done if you've got the questions today. As ever, nice little mix of questions. Don't really like proof questions. Usual thing, do like, subscribe, and I'll see you for the next one. Thanks all.